Hello everyone, in this course we build AI software that automatically aims and shoots at targets. Let me tell you what this course contains. In this course we collected data from inside the game to train an AI model. We labeled the data we collected. We trained the model using YOLOv5 with the data we collected. We wrote a target detecting algorithm using the model we trained. We wrote a mouse driver using Arduino Leonardo and USB host shield. By the way, the reason we wrote mouse driver is most games, such as Valorant, prevent us from giving mouse input with software. We found a general solution to this by writing mouse driver. Then we finished and tested the AI software. I shared all the materials such as the trained model, codes and dataset from Udemy. You can quickly follow the course using them. Also, there is one thing I would like to mention. This software cannot be used in ranked or regular games because the model was trained to work only on bots. Consider this course as educational, and you may be penalized by the game if you use the techniques in this course. Okay, let's start the course.
Hello, let's do the installations quickly. Create a new folder for project. Go official state of Python. Find 3.7.9 version and download it. Make sure to select Add Python to Pet option and complete installation the classic way. After that, search Google for Create Virtual Environment. Come this site, not this site, open this site, select Windows if you are using Windows. Open an CMD. Copy this. This will upgrade our pip version. Run this now. This will install virtual environment package. After that, run this code. Rename it. This will create a virtual environment. Name it YOLOv5. Okay, installations are completed for now. In the next lesson, we will write a script for collect data inside the game. Let's move on to the next lesson. Hello again. In this lesson, we will write a script to collect data from inside the game. Let's open an editor. Let's create a new folder. Create a new Python file. Paste the code I shared on Udemy. This code takes a screenshot of the center of our screen and quickly saves it. Let's install packages in virtual environment. Open CMD. Activate virtual environment. Let's write pip install image for pil. OK, complete. Write pip install OpenCV Python for CV2. OK, complete. NumPy was installed with OpenCV. Let's skip this and import keyboard. And time. OK, let's close this. I activated virtual environment in my editor. Let's try the script. OK, let's press UK. While we press UK, it takes a screenshot and saves it quickly. I am using this script to collect data from inside the game. In the next lesson, we will get inside the Valorant game and collect data. Let's move on to the next lesson. Hello again, in this lesson, we will collect data from inside the Valorant. Let's run our script. OK, now wake up bots. Now what we have to do is look at the bots and press the UK. After that, terminate it. Look at bots, press UK and terminate it. Look at bots, press UK and shut him. UK, it, UK, it, UK, it, UK, it. Again. Okay. Let's check datas. Okay, looking good. Every angle, every distance, every background. What is this? We need at least 1000 pieces of data for a good image processing software. I have already collected the data and shared it from Udemy. I will share all the components we will use throughout the course via Udemy. In the next lesson, we will do data labeling. See you in the next lesson. Hello again. In this lesson, we will do data labeling. Remember, you can download all dataset from Udemy. I will use data I have already collected earlier. Okay, let's create a folder for dataset. Create two new folders in this, name it images and labels. And again, create two folders, train and val, into them. Let's put the data we collected in the images folder. Ctrl X, Ctrl V, let's put 20% of the total data in the val folder. Now, let's go to site called makescience.ai. Click Get Started and drop images here. First drop train folder, and click Object Detection. Click here and create detection classes. In this project, I only detect bot's upper body, so I will write here bot only. If you want to make more than one detection, like head, legs, write them here, but don't forget the order. Okay, let's start project. Things we need to be careful about when labeling to get the object we want detect completely within boundaries. I am going to cover the head, shoulders and above the knee in this project. And select label. Make this for all of your images. I will not label all images because I have already done the labeling process. After labeling all the images, click Actions and click Export. Choose YOLO format and click Export again. Put them into Labels folder. Put them train because we use train images. OK, now let's label Val folders images. Click Make Sense, exit, drop images, click Object Detection, write same label name and start project. Label images. After the labeling is finished, click Actions and Export. Select YOLO format again. Put them into Labels. Put them Val folder. Again, I will use the components I prepared before. You understand the logic. Let's check out 793 file in this folder, 199 in this folder. But why aren't there 800 items here? It means some of the images are wrong. For an example, if you come across such an image while labeling, go without labeling it. If you have questions, don't forget to write them on Udemy. I will answer immediately. In the next lesson, we will do model training. See you in the next lesson. Hello again. In this lesson, we will train YOLOv5 model. Search for YOLOv5 from Google. Open Ultralistics GitHub and click collab symbol. Click copy to drive. We can close this. Run this cell. This cell will clone YOLOv5 to Google and install requirement libraries. Okay, after that, click YOLOv5, data, and find Coco 128 file. We must download and edit this. First, download it. Let's edit this file. Before then, open our dataset file and make zip this. After that, delete here and here and here. And here. Edit here like our dataset, file's name, images, train. Oh, sorry, like this. Okay, now we must write here number of our classes. In this project, I have one class. After that, write here your classes names. If you have more than one class, type it here in the order you labeled it. Like, for an example, if you do labeling in this type, you should write here this type. Number of classes is 3 and the order is same order you labeled. Okay, let's save this. And rename it. After that, import the collab. Okay, after that, open Google Drive, create a new folder, name it dataset, and model output. Put dataset to drive. After the installation is complete, come back YOLOv, click Add Drive, run this cell. OK. Refresh. Our dataset is here. We must unzip this. For this, add a cell here, right here, unzip Q, array of dataset, D, and 2 dot and slash. Let's run this. Okay, we did unzip the dataset. If you want to examine the graphs of the training, you can register to 1DB and run this code. Okay, now we can train our model. We need to change the parameters here. Remember, we collected our data in 640 pixel times 640 pixel squares. And leave it 640. We follow this article for changing parameters. For batch size, article says use the largest batch size. If we increase batch size, the model will be trained faster, but the system will use more RAM. Let's change it with 128. For the epochs, article said start with 300 epochs. 300 epochs is an ideal number for 1000 pieces of data. Let's do this 300. After that, rename this with the name of the file we just edited. Oh. Okay. Now we must select a pre-trained model. For this, come YOLOv5 GitHub web site. From here, we must choose a model suitable for our project. Speed is the most important thing in this project. That's why I choose YOLOv5 Small. After that, for the safety of training, we must save the model in a safe place. For this, we search for argument. Okay. Right here, project and our output folder. And check your runtime type. If GPU is not selected here, select GPU and save. Now we can start the training. We got out of memory error. Let's change batch size parameter to 64 and start training again. Okay, our training is started. This process will take a few hours. Okay, the training is finished. Let's check our model now. As you can see, the accuracy rate increased very nicely and went up to 0.92. That's pretty nice for YOLOv5 model. The training completed in 4 hours and model files saved in our drive. Let's check. X3, weights, best and last. The training is complete. Now let's write a software using the model. If you have a question in this section, do not forget to write. I will look quickly. See you in the next lesson.
Hello everyone. In this lesson we will install CUDA. Let's search for install CUDA and open this website. Select your operating system, architecture and version, and installer type, then download. In the next lesson, when we installing PyTorch, don't forget you must select the same version with CUDA. Okay, let's wait. Okay, let's open. Select your pet. Let's wait. Accept and continue. Fast. I understand. Next. Okay, CUDA installation is completed. We can close. See you in the next lesson. Hello again. In this lesson, we will start coding to detect targets. We will use the model we trained in the previous lesson. I will share the model we trained in the previous lesson from Udemy. The first thing we need to do is to install PyTorch CUDA. This is the most important package for this course. If you get any error, write me on Udemy. Now go to Site to download PyTorch CUDA. Select your operation system. For me it's Windows. Select your download method. I select pip. Language is Python. I select 11.3 version. OK. Copy this code. Go to our folder. Create a folder. Name it scripts. Open your IDE. Create a Python file. Select virtual environment. This way or this way. Okay. And voila. Okay, now paste the code here and click enter. This will take a few minutes. Okay, installation is complete. Let's test it. Import torch. Okay, torch is successfully installed.
Let's do one more test because it's very important. Okay, we are using CUDA. Then let's go writing scripts. Import OpenCV, CV2. Import numpy np. Import mss. Okay, let's install MSS package. For this, we can use this code. Copy this and write it to terminal. Okay. Any error? No. Okay. After that, come YOLOv5 GitHub stack. And find this PyTorch up. We are using 1.10 version, so we don't need to install this. Okay, let's check this article. I want to use Torch app for make course more easy. Okay, copy this. Now we have to git clone for use this. For that, come here again, download zip, and paste it here. Okay. Now copy this directory and paste it here. After that, write here custom, and delete this. That equals R. We need to write here directory of our model. For this, open drive and download your model. I am using best. Paste here your scripts folder and take its directory paste here. Okay, after that, oh sorry, and right here source local. After that, follow my codes with MSS SSQT monitor top left wait eight implement the array SQT after grep monitor results digital model snapshot size equals Altius Cook. Data frame results this part about get targets coordinates. Edit here. Okay, now draw rectangles. Okay, now right accept. Okay, now display this. Okay, let's try. Let's install pandas library. Oh, what's this? Install pandas. Install pandas. Let's wait. Okay, complete. Let's run again. Okay, I understand the problem. To be able to use YOLOv5, we need to download these libraries. For that, come here and write cd YOLOv5 master and pip install requirements.txt. Sorry, pip install r again sorry cd scripts cd YOLOv5 master. You must in cmd, not python, and write pip install r requirements.txt. Sorry for the mistake, I actually tested. Let's wait again for a while. Okay, let's try again. Oh. Finally, sorry for the errors. Now we are getting screenshot. As you can see. Now test this. Okay. Let's check our detecting script. As you can see, bots covered by rectangle. In this lesson, we will talk about why we need a mouse driver and how to make it. We will make our own mouse driver because the security systems of the games are not allowed to us give mouse input to games. I didn't research very much to learn this system can be detected, so don't use it with your main account without researching it thoroughly. However, we will use this method for education in this course, and we will make a fake mouse driver. The logic of the mouse driver will be like this. The mouse driver we will write will apply our mouse movements, and if the artificial intelligence software sends the code to the mouse driver will read that code and shoot the target. This code will be the distance parameter we wrote in the previous lesson. The diagram of this system is drawn on the screen. Actually, the diagram should be like this. As I mentioned earlier, we need Arduino Leonardo and USB host shield for the mouse driver. Arduino Leonardo must be R3 model. In the next lesson, we will continue with the Arduino installation. Normally, I don't show installs of packages in detail, but since this is a difficult topic, I have deleted my own packages and will install them from scratch. If the cards are ready, let's go to the next lesson. Okay, let's start with installing the Arduino. Let's go to Arduino's web site, come software and download the Arduino for your operating system. Run setup. Agree. Select all here and click next. Install. When the download is finished, click close. Okay, now run Arduino. Now connect your Arduino to computer, but don't connect your USB host to your Arduino during this video. For now, we will only use Arduino Leonardo. After connecting, we need to choose our port. For that, come Tools and select Arduino Leonardo port. Now, let's test if the Arduino is installed correctly. For that, come File, Examples, Basics and select Link. Then click Upload. Let's wait a bit. Yes, it says done uploading. Let's check our Arduino. Yes, as you can see, the Arduino is blinking. It means the installation is successful and the Arduino is working correctly. In the next lesson, we will do the necessary installations for the USB host. If you have any questions about Arduino installation, write to me. Let's move on to the next lesson. Yes, in this lesson, we will prepare our USB host for use. There are 3 places we need to solder on our USB host board. First, solder the 2 jumpers here, then solder only 5 volts here. Because our mouse works with 5 volt. If your card is not working
After the installations we will make in this video, check the solders. Now let's put the USB host on the Leonardo. Let's back to the Arduino, open Manage Libraries in Tools. Then find here USB host library. The library's name is USB Host Shield Library 2. Download this library by clicking Install. You can select version 1.6.0 as me. The library is not deleted even though I deleted the Arduino. I can't install for now. After the installation, connect your Arduino to computer again. Then come File, Examples, USB Host Shield, HID, and boot mouse. Then upload this. Make sure port is selected correctly. Okay, uploading is done. Now come Tools, click Serial Monitor and put your USB of mouse to Arduino quickly. As you can see, I can see here my mouse's movements. If you are getting output like this means installations are successful. These installations are not easy. It can cause different problems for everyone. If you run into any problems, write to me from the Udemy or look the answers to previously asked questions. Next lesson, we will upload our own script to Arduino to use it in games. See you in the next lesson. Hello again, let's continue. In this lesson, we will complete the mouse driver codes. First, let's copy the codes I shared from Udemy to Arduino. Now, I will explain the algorithms. These functions to make mouse clicks. These functions are also for mouse movement. The most important algorithm for our project is here. Let me explain this part. If you remember, we were generating a distance value in AI software. Next lesson, we will send that value to mouse driver, and the mouse driver will move the mouse according to that value. Here, we are constantly checking to see if there is a value coming to the mouse driver. By the way, the coming value to the mouse driver will look like this. If you notice it, the asterisk means the message is over. So, when we receive a message, we read the message until we see the star. After we get the message completely, we split it and assign it to variables. By the way, this message means go 50 pixels on X direction and go negative 100 pixels in Y direction. So, after the mouse driver receives the message, it determines the direction and moves there. If you notice it, I moved 5 pixels at each step here. That's because we are going to get the move done quickly. Okay, let's test it quickly. Let's compile the software. Let's open the serial monitor and connect the USB of our mouse to the Arduino. Yes, Arduino is moving our mouse now. Now, let's enter the values into a serial monitor to test. I clicking enter. As you can see, the mouse moved in the specified direction. Let's try another value. I clicking enter. As you can see, there was no response. But normally, we shouldn't give this value manually. Mouse driver will get this value automatically from AI software. Yes, we saved the logic of the mouse driver in this lesson. In the next lesson, we will complete the AI software. So, we will send the distance value to the Arduino. Okay, see you in the next lesson. Hello everyone, in this video, we are completing the software. Let's write the codes. Let's find the target's head level. Okay, then let's put a dot at head level. And draw a rectangle on the body. Then let's define the distance parameter. Let's add the calculate distance function. At here, I am going to copy paste again because I don't want to miswrite and waste time. Now let's import keyboard. And let's continue. I forgot this. If keyboard is pressed, a key, type the key of your choice here. The software will be activated when this button is pressed. Okay, let's continue. Okay, let me explain this code. The distance parameter can be in the destinations, and this function translates this value into this. Mouse driver reads and processes this format. The asterisk tells you that the message is over. Okay. Now let's import a new package named serial. This package will allow us to send data to Arduino via serial port. Okay, let's type Arduino serial. Let's check port. You must write here the Arduino's port. For me it's COM4 and type your serial rate. And give a timeout. Okay. Now we can send data to Arduino. Now let's write send coordinates function. Okay, then let's call the function. and give a sleep. Yes, it looks good. Now let's see if there are any errors and let's install the packages. I activated virtual environment. Don't forget it. Let's import keyboard. Actually install keyboard. Try again. Let's install serial. You must type pip install pi serial. Try again. Okay. It's giving error because I don't run Arduino. I am going to run Arduino now. Okay. Let's try again. The port is same. Yes, the software seems to be working. Now let's open the game and test it. But first, I want to remind you of one more thing. We skip 5 pixels each to make the aiming process faster. But if you want a more accurate aim, I suggest you reduce it to 3. Okay, let's open the game now. Hello, I made a mistake here. It just need to be import time. Like this. Okay. Valorant. There is one more thing. We have to calibrate when we get into the game. For an example, I can shot my target when I am pressing VK, but when I decrease my aim sensitivity, if you can see, I can shot. So you must calibrate your aim sensitivity. Okay. In the next video, we will test the software. Thank you for following my course. You can ask your question from Udemy. See you in the next video. By the way, if there are issues in the course, I will update the videos. Just let me know. Hello everyone, we will look at the final results in this video. As usual, I run the mouse driver software and connect my mouse to the Arduino. Don't forget to turn off serial monitor. Then I run AI software. Sorry, wrong file. Okay, everything looks good. Now let's get in the game and test the system. Okay, let's try. As you can see, the software successfully detects targets. And every time I press the Activision key, it hits the target automatically. Okay, it looks good. Now let's try speed mode in difficult settings. Okay, that's good too.